We are going to start a track of security topics. This is going to be 1 hour presentation with 10 minutes at the end for the questions. And I'm going to give the stage to Avisha Shafir. He's coming from Tel Aviv to tell us more about some stories about APIs. So please say welcome to Avisha.
Thank you. So, hello everyone. I'm happy that you are still here and you haven't run away to a nicer day than yesterday out there. In the upcoming minutes or hours, I'll try to share with you some ideas about API security. Now, we just had Richard's presentation about APIs and different ideas and design patterns, how to work with them and how to overcome. And he gave you several examples how you can use them. I can tell you that as a side listener, I already noticed several security issues in what he presented. Let's see if by the end of this session you'll be able to identify them as well. So I'm coming from many years of software development. I developed different kind of software for different kind of companies. I worked in several cybersecurity companies, and I want to give you some ideas about how things are going on when you are going to APIs. So some things will just wrap things up, so we'll make sure that we understand what we're talking about, but as we're just coming out of a session about APIs, it should be much simpler and clearer. So the first thing, when we're trying to start and distinguish what's going on in our software world today, we have basically two paradigms how software is being consumed. One is software as a product, as you know, when you are installing Chrome or Adobe Reader or Writer or whatever, or Windows. It's a software that we install and then we're using it, okay? And the second part is talking about different kind of services that we are consuming. When we are talking about Netflix or Datadog or different services from Amazon, we are not installing anything. We're going to a specific URL and we are getting the answers from that service as we're working with them. Now, there are several basic differentiators between these two. When we're talking about software, then you have versions you are installing. You can go to your Chrome about, and you'll see exactly what is the version that you're using. And if there is a newer version, you need to upgrade it. Sometimes you need to buy it not with Chrome, but with Adobe or Windows and stuff like that. You need to actually pay to move to the next thing. When we're talking about services, you don't need to do anything. Everything is a problem of the service provider. Whether the version or anything, you have no idea. You simply pay per use, or if the cost is zero, then you're not paying. But the concept is that you don't need to do anything about it. So how can we really get to use these services? Quite simple. And when we are talking about the services, we're talking about all sorts of things that we're using for our home life, I don't know, the different application that we are using, or the different services as software developers that we are using in order to build other software, or different infrastructure. And this is the point in time to tell you that actually I'm a Mac user. Nobody's perfect. And when I moved my presentation from Mac to PowerPoint on a PC, it cut. So sorry for that. The main idea is still there, but this is what happens when you are jumping between different kinds of products, and they say everything is it's PowerPoint on Mac and to PowerPoint on PC. It doesn't work exactly the same. Now, the way that we are able to use all these services is because they're all communicating through APIs, okay? Application, protocol, interface. I was in university learning computer science over 25 years ago. We talked about APIs back then. It was C. Nobody liked it. It was complex. Nowadays, it's very simple in different kind of language where you can do the different APIs. But we are talking about APIs that are communicating. This is the way that we are serving the different services. Okay? And if we're looking about web application, 80% of the web application or the mobile application communicating with the different servers and applications that they're using is based on APIs today. Okay, so it's important to know how to write good APIs. In a minute, we'll discuss why it's important to do it in a secure way as well. When we are talking about in cybersecurity, we are always talking about the attack surface, okay? Now, the reason I'm walking from one side to the other is to make sure that you're not falling asleep after lunch, okay? So stay with me. I'm here all the time. So different layers of the application provides you different capabilities. On one hand, it is much easier to hack an application and go into the actual code and do something in the application. From capabilities point of view, there is not a lot I can do when I'm hacking a specific application. I can do what the application allows me to do. When I'm talking about an operating system, okay, the blue dot over there, if I can hack the operating system, I can do whatever I want. Okay, I have full control about anything. It is harder. It's not impossible, but it is harder. Okay, so we can understand that there is a line going from what we can do, the simplicity of breaking in, and the power of what I can do with it. Okay. Now, when API are coming into the picture, it's a different picture because APIs are there. It is unfortunately quite easy to break into an API, and the capabilities are huge because everything is being done through the API. And this is why it's important that we'll notice that we write the APIs in a way that is protected properly. Okay? Any question to this point? Do you have any idea on what I'm talking about? Are you with me? Anyone? Okay, you're alive. Good. Okay. Okay, so let's take an example on the simplicity and the power that APIs and services are providing us. Let's say that I want to know where somebody is located right now, okay? Now, in a technology kind of way, okay? Let's think that I'm part of James Bond team and I want to locate a specific person, okay? So one thing I can do, I can have different satellites and different kinds of tools, very expensive tools, that can break into his mobile device with some kind of a zero-day vulnerability that he's not aware of, and then try to get the information and use different satellites. And I can do as in software. I can send him an email and hope that he will click on the link and it will install something on his device. There are different kinds of things that I can do in order to try and locate this person. Now, this requires a lot of money because I need to know who I'm targeting and decide, because I don't want the zero-day to become, not a zero-day is a vulnerability that nobody knows about. If I don't want the vulnerability to be familiar and be patched, then I'll decide that I'm using this only on very specific cases. On the other hand, I can go to services. He's using something to navigate, right? If I'll hack into the APIs of the services, I can know exactly where he is at any given moment. I don't need his phone. I don't care what version of mobile device he has. I don't care anything. I'll simply hack into the service, and then, quite simply, I can know exactly where he is. Okay, in a minute, one of the examples that I'm going to show you down the road is of one of the things that many of us are using and can tell anyone exactly where you are, whether you like it or not. Okay. So the API, when we're talking about the API ecosystem in general, okay? So one thing, there are some characteristics about it. One is that it's very quick release cycles, okay, because we're saying it's a microservices, sometimes even said nanoservices when we're talking about serverless and stuff, very small piece of code that is doing something. It has an interface, you can come in, you can connect with it, you can get the answers. So the cycles of APIs are very, very quick. Of course, it's a microservices architecture, and the integration is very, very simple. And by the way, when we're talking about these quick release cycles, the way that we are building software today, we're using a lot of services and APIs of other vendors. For example, if I'm building an application and I need a map in my application, I will not develop a map and put all the maps inside my application. I'll simply use the Google or the Microsoft or whatever API for their map application, and I'll communicate with it. The problem is that we created what is called software supply chain risk. It means that if somebody will hack into the maps of Google, then he can hack into my application because I'm communicating with this application, and then there is the option to do, it is called in cyber lateral movement, moving from one object or from one service to the other one. Okay, so this is typically the kind of things of this environment. And for a hacker, when he sees these kind of things, this kind of concepts in the world of the API, he sees opportunity, okay? A bit later down this presentation, I'll show you some exploits based because of this kind of capabilities, okay? So when I'll get to that, I'll tell you, do you remember the slide that I showed you with the characteristics of the API? This is what I mean. Okay, now if you're monitoring or if you're reading the different technology newsletter out there are hundreds, thousands of them. The best one, of course, is the one here in Romania, the TSM, but there are others as well. And you can see every week that there is some kind of a breach because of the of cybersecurity issues. Now, you know, when you're looking at the T-Mobile API was breached, we are talking about millions of things that were stolen and bad things. Bad actors can do bad things about it. So the problem is very, very strong, and it's very, very there. Now, the reason that we have this problem is because we have an enormous amount of APIs and applications that are using APIs. It's because we adopted agile methodologies that saying, let's develop very, very quickly, and let's have pipelines and CI/CD, and let's push the code to production immediately. And because we're doing things extremely fast, then it is becoming challenging to verify that everything is working properly. It's true with functional, when we're talking about functional testing, how do you do them? About performance testing, how are we making sure that the application or the service will have the stress, and it goes all the way to security testing. And we'll talk about security testing and the implication of that as we'll continue with this discussion. Okay, so there are different reasons why we are going there. Now, I want to share with you, there are many ways to hack APIs and to hack applications. I'm keep moving for you, and you need to run after me with the camera. I'm sorry for that. I'll try to be more static. There is an organization called OASP. OASP is an organization that helps define by volunteers from different companies, best practices for security for web application and for APIs. And there is an OASP security top 10. There is a top 10 for web application, there is top 10 for APIs. I have a slide later with the URL of them, and I strongly recommend, if you're not familiar with the website, to go and have a look, really educated. Okay, I brought some of the things here to make your life simpler. And this is the 10 most common attack types that happens, and the most riskiest one. Okay, so just as a starter, let's start and go and understand some of them. Let's see some examples to some of them. So the number one, now it's written API 1 to 2023 because 2 or 3 weeks ago, the latest version of the API Top 10 was released by the OASP organization. There is another, you might find in some other places, the numbers 2019, because the older version was 2019, but you are very progressive. You are now seeing a version that was released 3 weeks ago. So it's not widely known yet. But broken object level authorization, typically it is called BOLA by the acronym. It's extremely, unfortunately, it's extremely common, and it is 100% because developers did bad job building the software, and we haven't tested them properly afterward. So if we'll see an example, okay? So you can see here, there is a URL from, let's say, an e-commerce website that is saying that if you want to get all the revenue, when I'm talking about e-commerce site like Shopify, like eBay, where you can register and manage your own shop on that platform. Okay, you don't need to buy anything, you just open an account and you can manage it. Now, there is an API, let's say that I have an API that I can put my shop name, and then I say revenue data JSON, and I'm getting everything. Okay, this is the endpoint that returns the everything for me. Now, in order to do that, I need to be authenticated. Okay, I have my shop. I'm logging into with my credential, with my user and password. I'm logging into that platform. I'm running this, and then I'm saying, interesting. I wonder how my competitors are doing. And I can simply change the name here to the name of the competitor. Now, I'm authenticated to the system. I have my own user. If this API is not checking that there is a correlation between who I am and the object that I'm trying to retrieve the data, and I'll tell you a secret, you can try it later at home, most of the APIs that you will approach are not making this sanitation, and they will not check it, and they will allow you to do that. All of a sudden, you are getting your competitor data. And, I can get it, I can do some kind of other, they have a public API probably to get all the shops that are working in their website, and then I can move from one to the other, and I'll get all the data. Everything that I'm telling you here is coming from actual experience, okay? Things that we saw that actually work, okay? So this is an example, and if I'm looking at that example again, okay? So the most dangerous APIs are those that are getting some kind of an ID, okay? So on my authenticated, no problem. I can put my ID, and then I can get all the details. But if I don't put in place a system to make sure that I'm not able to look at other objects, then I can change the number to 2, and I'll get the details. It works. Try it. It's fun. I'm not encouraging anyone to hack to anything. It's illegal, don't do it. But it's fun. Okay, so what can we do in order to prevent it? So there are different kind of things. The main thing is, guys, when you have things that are relying on an ID, UUID, SSN, there are different kinds of numerators or stuff like that, identifiers. Make sure that you are matching between the authenticated user and the object that he's trying to access, okay? It's not that complex to do it. You can do it, and then it makes things much simpler. Other than that, it's good practice not to have with ideas one after the other, okay? Make them change the pattern, 5 letters, 6 letters, 20 letters. Make the hacker sweat if he really wants to do it. Now, it doesn't mean that he will not try to enumerate and run this kind of brute force attacks. It does mean that it will not be that simple that I can say, oh, no problem, from 1 to 2,000, sure, I'm running the numbers and I'm getting all the information. Okay? So this is the idea behind BOLA. Questions to that? Yes, you'll be able to ask questions at the end, but you'll forget. So if you have a question for that, ask me now. Okay, cool. That means that either I was clear, or you have no idea what I'm talking about, and I'm here standing mumbling to myself, but life is nice. Okay. Okay. The second one. Broken authentication. Okay, so again, it's more about the same things, and it is more about the token. After I'm doing, if we're talking about how the different authentication mechanisms are working, I'm giving my user my password somewhere, and then to some kind of a service, to an identity management software. It can be Google, it can be Microsoft, it can be Ping Identity. There are different kinds of companies out there providing this kind of a service. And then I'm getting a token, okay? And APIs by nature are stateless, okay? every time I'm calling an API, he has no idea that I talked with this API or with another APIs from the same application, and I need to give him some kind of information that it's still me. It's part of the conversation that I have with you. And for that, we have the tokens that are doing this kind of activity. Okay? Now, you can see here a list of vulnerabilities that are common every time that you are using any kind of an authentication. Okay, I will not go through every one of them, and at the end, as I said, there is the link with all the data, or you can picture it. But every time that we are not making sure that our authentication is properly, then we are providing the API very sensitive. Now, a typical example. Now, this is something that falls into it goes here in the API 2 category, but it goes also, I think it's the 6 or something like that, which is about configuration. The very basic thing to do with your API is put rate limiting. When somebody is approaching a logon, an authentication API, okay, I can make a mistake once, I can make a mistake twice, I can make a mistake 3 times. More than 5 times, I will not do a mistake in my password. And if I did, block the user, give him a captcha, give him some kind of a mechanism to make sure that it's a human, but don't let him continue. If you are not putting rate limiting, meaning that you can have access as a specific user, you can access this endpoint up to 5 times in a minute or 5 times in 10 minutes or whatever rate limiting you're putting your APIs in danger. That means that I can easily do a brute force on you. I can bring up 3,000 different lambdas on Amazon. It will cost me nothing, and I can, with different IPs from different regions, and all of them will go into that and will ask it. So, if you don't want this to happen, and if you don't know, here you can see the different kind. There's some password. This is a brute force attack. When I'm trying different kinds of password, there are dictionaries out there with the most common passwords. I'm sure no one here is using one of the most common passwords. I'm sure of it. But you'll be surprised. Every time, when I'm a software developer, so originally I used to write code, and then when I moved to cybersecurity and I started to do this kind of thing, I said, nobody is that dumb to use the 1, 2, 3, 4, 5 password. Nobody will do it. You're running brute force, it opens 20% of the users. It happens. So, and don't be confused. The end user that put the stupid password will come to you as the developers of the application or the API will say, it's your fault. Don't go there. Make them do a stronger password so these kind of things will not happen. So understand the different flows that you are using. Know exactly what you can do. Force them to do two-factor authentication, meaning password, something I know, and a mobile that gets the answer, something I have. It can be tweaked as well. It's not, don't think that if you have two-factor authentication, you're covered, but it's decent. Okay. Broken object property level means something similar to the first one that we talked about, the object, meaning that I can query or interact with another object that I don't have the authentication to. When we're talking about the property, it's about the content that you are exposing. Now, in different kinds of activity, you can provide to a legitimate user by exposing more properties that you intended to provide. You can let them away how to go in. This is an example of a Twitter kind of an application, okay, where I can say on a specific video, I uploaded that video. Now I can say I can change the description, okay, but I created this, it's a funny video, but YouTube, for example, or tweet, it doesn't matter. They decided that this is not an appropriate kind of movie or clip, and they blocked it. So I tried to change it a bit what I'm sending, and instead of just sending the description, I sent blocked false. It works. Now, the same goes, by the way, when you're going to different APIs dealing administration of users, and let's say that you see, now, in a minute I'll talk how to do it. I want to modify my last name, okay? I want to change my last name from there is a typo, I want to change, for example, in the website of the conference, they forgot the last letter of my, I want to fix it, okay? But if I can do it, I can add additional, for example, let's say that right now I'm a regular user. I can use this kind of a method to make myself admin. Admin equal yes. Admin equal true. It works. So this is the idea behind this vulnerability and how you can tweak it. Now, you probably say, okay, but how do you change the payload that you are sending? So typically when we are addressing an API through a mobile application or a web browser, you can see in the URL, in the URI, you can see exactly that I'm calling the host / until the endpoint, and then there are parameters. Okay? Now, there are different tools which are free, like Postman, the community version, like Bath, which is an open, the community version is very, doesn't cost anything. You can put it, and then it's a kind of a proxy. And you can easily define it. You can simply add a different port. It will go first there, and then from there it will be forward to the end goal, and then you can tweak with everything and do whatever you want with the payload. Okay? So and there are other tools. This is just 2 examples, the most common examples. Okay, so this is what we can do with that. And this is how we can prevent it, okay? So make sure that you are sanitizing the payload. Allow only the fields that you want them to actually use. Don't be lazy. Don't let them use any key or any property out there and put it and looking at it, okay? This is the #1 kind of things, and make sure that you are returning exactly what you need to do. Okay, so we're almost at half of the presentation. Just another 30 minutes, and you'll be free. Now, it's an excellent time for me to make an audio selfie. So I'll remember that I was here. So this is your time to say, hey! Okay, you're awake. Okay, so I'll run through the others. I will not go over every one of them because I want to show you some additional examples, and I want to give you some additional examples of real attacks that we have conducted in our research lab. Unrestricted resource consumption. You know, when we're using web application, we usually use Amazon or Google or Azure or some other vendor, and we're consuming a lot of resource from them, and they are charging us by the traffic, okay, by the action. If we're not putting rate limiting or other security controls, it can cost us an enormous amount of money because I can send questions, you know, as a bad actor, a lot of them, very quickly. Okay, so if you don't want to have on your application all of a sudden a huge bill, and don't understand why you need to pay $1 million to Amazon, which will be very happy, or to Google, this is exactly the security problem with this one. Okay, so you know, if I have something that sends an SMS, I can run it, and I can send SMS to myself all day long. It will cost the provider, so don't go there. Broken function level authorization, typically called bafla, which is, I don't know in Romanian what it means. In Israeli, it's a candy. In Hebrew, it's a candy. So this is a candy kind of thing. And again, it's all about understanding the authorization, what you can and what you can't do inside the properties that you are using. Okay, so I'll go a bit faster under the around these ones. Business flow. Not all business flows were born equal. Some of them are more sensitive than others. For example, if you're running an e-commerce site, then the checkout is more sensitive than others. Some of the admin kind of flows that you have there are more common, are more sensitive than others. You need to make sure that the most sensitive business flows that you have in your application are well covered and are not open. Now, there is a myth among developers saying that, hey, If I'm not documenting the API or the endpoint, if it's not something public that I'm telling other developers that they can use in the documentation that I'm exposing, nobody will use it. Wrong. For the hacker, it's the best thing ever. Every time I'm trying to test a different kind of a site, one of the most common things, I'm looking at the different kind of endpoints that it has, and then I'm adding at the end /admin. I'm in there. All of a sudden, if I'm getting, sometimes I will get a 404, which is okay. I have no idea if something is working there or not. Sometimes I will get an error mistake that I'm missing some of the parameters. I'll show you a bit later an example where the engine, the server is telling me what I'm missing. And I'm saying, thank you. And then I can continue with it. So this is the idea behind this. SSRF, server-side request forgery. In many cases, we want to bring additional information from a different URL. Sometimes it's in the payload. Okay, I'm adding in the payload a different kind of a URL to bring more objects. Sometimes even I'm putting it in the URL as a URL parameter. Okay, this is the easiest kind of thing, how to put malicious code into your end users, because I can replace the URL that you put in with a different one. It's not that trivial, okay, because I need to be some kind of a man in the middle and to see how I'm making sure that it sends. But the idea behind SSRF is the ability to change different kind of URLs to a malicious one of the bad actors. Okay, security misconfiguration, meaning that you are using different kind of tools, whether you're using RPG or API gateway and stuff like that. There are configuration over there. Make sure that you're doing them properly. This is another common mistake by developer, improper inventory management. Okay, I have my first API. In many cases, you'll see in the URL that the endpoint is v1/users, v2/users. When I see v2 or v3 or v4, I know that there is v1 that somebody forgot to remove, and it's still accessible, and it is not well protected. So the first thing I'll change, I'll v1. Let's see what's going on there. Okay? This is how a hacker thinks. So if I'm creating new version, first of all, don't put the version in your endpoint path. Okay? It's asking to be hacked. But even without doing that, remember that if you have versions to your different endpoints, you must remove the old endpoints and don't let them be accessible. It is so common that I'm saying, oh, I'll keep this up because maybe I have a problem in the new one, so I'll be able to do a quick rollback and go back to the old one. Okay, it can take a week, it can take 2 weeks. Remove them. Developers forget to remove them. Now, when I'm saying that the hackers are attacking, and it goes in a minute when we'll talk about the ways of mitigation and the idea behind shift-left security testing, there are crawlers, there are tools, there are different kinds of tools, scanners, that helps you understand what is the posture of a specific website or a specific application, and it brings back, it crawls, it's not human, it brings back all the different URLs that your website or your application has, your web application has. So even though you think nobody will ever know that I have a v1 because it is not documented, how will they know that? The crawler will go. He's enumerating everything. He's doing one thing after the other, and these crawlers, the scanners, are quite good. They will find anything. So if you have malicious intent, it's a good tool. If you just want to make sure that you're not being hacked, then you need to make sure that you are not enabling this kind of management to your inventory. It goes to versioning. It goes to undocumented APIs. Undocumented APIs are extremely vulnerable for attacks. And the last one. Yes, we said that, and Richard in his presentation even talked about how we're using Stripe for payments and how we're using different kinds of API from third parties. Now, people trust other people, and developers trust other developers. And if I'm using a third-party library, I trust them that they're doing the right security controls and making sure that nothing bad will happen from there. Unfortunately, it's not true. And you might think that they're doing everything correct and you are using a very common like Stripe, like Google, like Uber, like I don't know who else. They have mistakes, they're doing the same kind of mistakes, so don't trust third-party APIs. You need to make sure that nothing bad is happening in the relationship between your API and the bad API. Okay, so this is the page of OWASP that shows the content, some of the content that I shared with you, and if you're a real hardcore developer and you need it in a GitHub kind of style, it's the same text, but this is in GitHub and this is a website. Okay, so have a look. If you have questions after you read this, feel free to reach out. I don't know if I don't remember if I put my email at the last slide. Never mind, I'll give it to you. Feel free to ask questions if you have. Okay, so one of the ways, the things to make sure that we are building our software in a secure way is testing them, security testing. Okay, there are different kinds of methodologies how to test. I'll give you a hint. The presentation, not the one after me, but after that, is going to talk a lot about the ideas behind shift-left testing for security, so stay tuned. You don't want to miss it. I hope you'll stay. The last one is a tough one. So when we're talking about a basic pipeline of development, okay, so we are committing our code, we're doing a pull request or whatever methodology we're changing, we like, and then we're doing some kind of basic testing. Of course, we cannot do the real security testing at that phase, and then we're continuing and we are building, and it's a nice pipeline, and we have a unit test, an integration test, a functional test, and verification test. And in the past, we used to do after the user acceptance test, we used to do some additional security testing. DAST stands for Dynamic Application Security Testing. Okay, it's a method of tools that are using different kinds of scanners and simulator to simulate an attack on your code and see whether it works good or not. There are many DAST tools. Some of them are complete crap, but you'll feel good that I ran a DAST tool and nothing bad came out of it, but they're not working properly. Some of them are brilliant. Okay, so find the right one. If you want recommendation about DAST tools, talk to me. I'll be more than happy to share with you what I believe in. It's my personal opinion. I don't know if it really works as a thing, but there are some good. So the idea in the past we used to do after the user acceptance test this kind of test, and it's a bit too late. And the whole idea of shift left is instead of doing the testing at the end, shift left comes from testing, okay, from functional testing originally, meaning let's push them to the left of the development cycle, as close to the build and to the PR as possible, and make sure that we don't have security flows at an early stages of our pipeline, okay? So we see a trend of going from this section to this section. Specifically, I stole this presentation from Bright Security. It's not my slide, it's Bright Security. I'm working for Salt, if you haven't seen in the first slide. So this is the way that they are pitching that it's worth doing the security testing. And of course, you know, this is the same slide, you know, that we used to see on functional testing. The earliest you find the problem, the less it costs you. If you'll find it at the beginning, then it costs you a small amount of money. If you'll find it in production, this is a rough estimation, by the way, because if you are breaching a compliance, a GDPR or something like that, then it might cost you millions because you'll get fined. But let's try to do it as early as possible, and it will take us to the right place. Okay, so I showed you before some of the characteristics of the APIs, and I told you that I'll give you some example how this kind of things are opportunities in the eyes of the bad actor. Okay, so let's see some use cases. Everything that I'm showing you here is real companies. It's real things that our security researchers found, okay? And everything was fixed by now, okay? Don't try this. This was already fixed. Nothing will happen here. Okay, so one of the biggest fast food companies in the US asked us to have a look on their system, okay? They are huge, they are really, really huge. They are developing, you know, it's a company quite young, They understand software development. They don't have a legacy system. They really built a state-of-the-art application, web application, based on REST API. Everything is in different kinds of APIs. The public APIs are very well designed. The internal ones are very, very well designed. And when we looked at it at the first site, we thought, oh, everything looks okay. Okay, the end. We can tell you, you're good. But is it really the end? Let's have another look. So we looked on one. Okay, now here is another apologies as a Mac user. In my Mac, when I'm going to this slide, the small letters are coming out and become big. Here they don't, so never mind. I'll give you the main thing that you need to know about it. The application is written in JavaScript, okay? JavaScript typically, when you don't want hackers to look into your code or to reveal secrets or business secrets, you are obfuscating them, okay? So nobody can read it. But even when you're doing obfuscated to the code, you can always find some kind of URL that you can understand exactly what's going on there. Now, they have a well-documented API inventory that they are sharing with different partners that they can use, but we noticed that this API is not challenges, the endpoint challenges, is not well documented. It's not documented at all, not well and not well. It's not documented. So we said, okay, interesting. Let's see what's going on there. So we called it. And then, after we called it, we discovered that this is a GraphQL. The most common type of APIs on web application is REST, okay? After REST, we have several. We have the legacy, which is SOAP and XML, which legacy companies still use, but it is not very common today. REST is the most popular. GraphQL is stepping in. GraphQL is out by Amazon, and they're pushing it quite hard. And there is another one, RPC, which is coming from Google, and they're pushing them as well. I have a list at the end. Specifically, GraphQL is very attentive to the user, to the developer, and wants to help him. So we discovered that, okay, it's a GraphQL. Okay, so we just send, okay, challenges, and we said some kind, GraphQL, there is a keyword called query. We send query equal A. We had no idea if there is a or something like that. Now, he told us, no, there is a mistake. Okay, GraphQL, but GraphQL errors are quite good. So we tried a bit more, and we said, we change it to some kind of an object, query equal user. And then GraphQL answered us, I'll read it because you can't see, did you mean get user? Interesting. Okay, yes, definitely, I want get user. Okay, so I changed it to query get user, and it continues. GraphQL continued to give me different things. Where is your parameters? You're missing that, you're missing that. And at the end, after we took all the different kinds of errors that the GraphQL gave us, we saw that if we'll say query for get user with some user ID, whatever, where 1, 2, 3, whatever, doesn't matter, and then we'll ask for the ID, first name, last name, email, phone number. It took us time, okay? It's not something that you're doing in 5 minutes. But we got all the information, and we ran it in a batch, in a Postman, and we got all the list of the user of that specific company. That was a bit of a problem from the perspective. So you need to know that if you're using GraphQL, which is awesome. As a developer, I'm telling you, it's cool, it's fun using GraphQL. It saves you so much time, because in GraphQL, you can have multiple requests to the endpoint in one request. You don't need, in REST, you're doing get, post, put, delete, everything. Every time you're sending one command, one function. In GraphQL, you can send in the payload. You can tell him exactly what to do. So it's cool, but it's very nice to customers, to the developers, and that was the really end. So we patched it, we fixed it, everything is good, and the company is now happy. Okay, I'll run on this very quickly because I have 2 examples that I want to show you just the concept. Bola, we talked, it's the API one, and what I want to show here is an example for a company, a financial company, never mind exactly what was the story of the company, and we saw, by the way, this company is using REST. How do I know it's a REST? Because they wrote it in the URL, so it's a REST, okay? No doubt about it. Okay? So, and we saw that you can retrieve a file, and you need to say what is the type, PDF, and we saw, we don't know why, but file equals something, and the idea is equal the same. We said, okay, let's play with it. Let's enumerate it. Let's try to throw numbers at it and see what's going on. Okay? So we did that, after many tries, this is the 3 parameters that I said that we need to file, we just randomly ran some numbers, and then we got this. Now, it's obvious when you're looking at this kind of thing, that it's written content type, image. Okay, so we converted it into image, and what we got is a check. So we found that we can take out all the checks of and other financial documents from this company, and it was embarrassing. And in the US, if you have the social security number written there and the number of the account, you can really withdraw money with the information on that check. So that was nice, that was fun. We did another interesting thing with them, and we saw that they have another endpoint with a post thing with commit at the end, and we saw that they're using the uname, they're putting it in 2 places. Once here, John Doe, here you can see, John Doe in the cookies as the authentication token, and we saw that it's in the payload as well. And immediately, because we are really fond of Bola, we thought, interesting, what will happen if I'll keep this the same, but here I'll put something else. So we tried, and it's deleted, by the way, it's a command to delete someone. So we tried. We are responsible. We did it with users that we created in the system. We didn't really delete anything to the company. But this is the authenticated user, sol.security. This is the authenticated. This is the one that we said, let's delete it, sol.user1. It's not the same one. This method, this is a Bola where I can do whatever I want once I'm authenticated, and I can play with the users of that system. Okay? Now, this is frustrating, okay? This is something that shouldn't happen and should be dealt with, okay? We also found that we can get all the information of the users as well, but I'll skip that. I want to show you the last one. This is a taxi company, okay? Today, when you want a taxi, you're going to the application, you're asking the taxi to come, and they come, and they take you wherever you want. Quite a big one, okay? And they're using RPC kind of thing. And there is a function, we saw that they have an undocumented endpoint called add driver, okay? So in order to add driver, you need to send a number, a phone number, or you can send an email. Now, we did that, and of course, we got an error because we are not drivers of that company. But interesting, from some reason, it returned a driver's ID. So now, 2 things. First, we learned that this exists, and second, we learned that this is the pattern how the different drivers are being managed in that company. So we try to do other things, and we find additional endpoint get consent, screen details. It's when you're saying that you are allowing things to happen. And this time we send this user ID that we found by accident. We have no idea who this person is. And we got everything from that user, including the mobile token, how to communicate with the server. So now I can take this, and I can do whatever I want on that person's behalf. I can tell them to change the number of the phone number and then authenticate it myself. I can tell them, hey, the money that he's making and you need to pay him, pay it to me. Why to him? I can do whatever I want when I have this token. Okay? Not good. If you haven't understood the cat, not good. Okay. Now, you might tell me that you never heard of Acme Taxi. And you're right. Because actually, it's Uber. And to the best of my knowledge, Uber is working here in Cluj, right? So, by the way, if I can do this to the drivers, I can do this to the passengers as well. So you think that you are safe when you are paying with your PayPal in Uber. I can take some money from there. No, I'm kidding. This was reported. This was not done by us, by the way. This was done by Anand Parkash, the researcher that published this, and it was already fixed. There is a common way, white hat hackers, when we discover some things, first we're approaching the company, we're telling them what we discovered. They have a period of time where they can tell us that they're working on it. Some of them are giving us money for that, some of them are not, most of them are not. It's a shame, but still this is the idea. And they are fixing things, and then we are publishing the story. So this is the story about that. Okay, so you might think it's very easy to hack an API and let's stop using APIs because everything is a breach. No, there are good practices how to do it. It's not that simple. You do need to know what you're doing. You do need sometimes to get into the communication. You do need sometimes to be in the same network in order to get the information. So it's not that trivial, but it's not very difficult on the other side as well. Now, remember, APIs are being attacked mostly by people, by hackers, by humans that are sitting. There are some scenarios where we see botnets that are trying to hack different APIs or different websites. It's a different use case, it's a different story, it's a different presentation, maybe next year. But for today, typically it's humans, and because of that, each API is different, and it is hard for the hacker to know, and every time I need to find a 0-day something that I haven't seen before. By the way, the reason I think developer is doing, in order to fight bots, they're saying, I don't care if I'm going to serve the request or not, I'm sending back a 200 OK. Okay? So even if it's a mistake and it's supposed to be 404, I'm putting 200 OK, and then I'm writing something in the response that it was not OK. It's good for bots, okay? Even though the new bots don't care about the 200 OK as well. But then you are confusing everyone. It's not 200, return 404 or whatever you need to do and deal with the error as it should be. So what I'm saying here is hacking there is a challenge. There are different types of APIs. There are different kinds of documentation. There is documentation. I'm not sure that I heard correct the question on the previous session about documentation of API. There is a standard how to document API. It is called OAuth. In the past, we used to use Swaggers. Swaggers originally were invented by a testing company to do mock simulation, okay? And today it is called OAS, Open API Standard, and you can document API with security things and with functional things. So, but there's so many things to document over there, so it's very difficult to really know what's going on, the different kind of documentation. And I'll skip this, and I'll say that thank you, and I'm sorry if I spoke a bit fast in the last 5 minutes, because I wanted to show you the examples. Now it's your time to have questions, if you have any.
Yes, we have one here.
Hello. Hey. Thank you for the presentation. My question refers specifically to GraphQL. And what are the best practices of securing GraphQL at field level, given the potential explosion of complexity?
Okay, great question. So first, I want to refer you to the URL that I showed on the screen from OAuth. There is a list, there is a checklist how to do properly mitigate all of that. It's a very long list, so if I'll start telling it, I will never end. But the main things, by the way, REST and GraphQL, it's pretty much the same. Make sure that the authentication is properly, the passwords are correct, and you are not you are putting rate limiting. You are not exposing data in your message. Not it is called verbose answer when you are saying you are sending too much in the response. A typical example is you are sending something is illegal in the request, and you are saying this is Nginx 5.2. Your request is not going to be served. You just told him that he can look for CVEs, for vulnerabilities, for Nginx 5.2, and he can work on that. So the concepts are the same, but either I didn't answer or you have a next question. Say it out.
GraphQL is a bit different because you do resolvers at field level. So at field level, you're lacking context about the rest of the fields you're getting in a query, and at the same time, it's the same like doing ACL over REST. So you have very granular permissions, and you could potentially end up with a graph for privacy. So what are best practices here? Because definitely it's not feasible to have it that way.
So the best practices is simply make sure that to build an RBAC or an ABAC, flow tree of authentication. If you don't know what I'm talking, Google RBAC, Google ABAC. It will explain to you how to build a hierarchy of authorization to the roles and to the different users. And this is really what helps in this specific situation. Yes.
So I had a question about Dust. You said you have some personal preferences. Sorry, did you understand?
No.
So you said about Dust that you have
Yes.
some personal preferences.
Yes. So, okay. So, personally, and I'm a bit biased here because I'm working with these guys, I think that Bright Security is doing a very good work. Are you guys doing Dust as well? So, Snick will tell you in a bit what they are doing. They're not doing Dust, but Bright Security is doing a very good job in that. Rapid7 is another company with a good Dust tool. Who else is very good in Dust? Which one? Indictive, right, Indictive. Indictive? Indictive, yeah. Indictive is the biggest, is the most common one. I know them, I haven't tried them, so I don't know if they are good as they are claiming to be, but there are rumors that they are really good.
Thank you.
Sure. Who wants to go last? Because then my time is up. Is here.
Regarding the passwords that were really simple for some users, like 1, 2, 3, 4, 5, 6.
Yes.
I saw some, I don't know, studies or something like that, that introducing these restrictions, like minimum 8 characters, must have one special, actually helps the hackers to tune their dictionaries. And is that true, or?
Yes. So the question was about, if I understood correct, about best practices of setting the password in a right way, which is not, or the IDs of the endpoint.
Imposing some restrictions on how on the password for your customer.
The main thing is don't enumerate them. Don't put one after the other in a very common thing. If you can do them spread all over the place, sometimes with special characters, sometimes without special characters, make them different, unique. Now, it will slow the hacker down. It will not stop him. If he's really want to break into that, he will find what is the pattern that you're using, because at the end you'll have some kind of a pattern. But it will slow him down, and in many cases it will tell, oh, I don't want to waste my time on that, I'm going to another company. Now, the analogy in my, you don't need the best lock on your door at home. You just need something that will look more tough to open than your neighbor, okay? Go to my neighbor, leave my house alone. That's pretty much the same thing here.
Okay, thank you.
Sure, yeah.
I was thinking about, in your real life, how do you protect from hackers when you use websites and stuff like that, when you use your credit card? What are your patterns for protect yourself?
Okay, so this is a good question, but from the other side, because what I was talking is how to protect the software that is delivered. You're asking me as a person if I'm not afraid to put my credit cards and stuff. The one thing I did, I selected the credit card that gives me the highest insurance. So if something bad will happen, they will pay for it, not me. But there are common things when you're going into, if you're going to a login page of a website and it is not HTTPS, there is no TLS setting there, don't buy that. It's wide open, it's exposed, don't use it. Try to use only sites that are well known. Make sure that the site looks, there is no typos, because a lot of the hackers are playing with the DNS and putting Amazoni. adding an I at the end, and all of a sudden it's something completely different, which might be malicious. There are tools to deal with it. There are reputation feeds where you can really learn, get a score for specific URLs and IPs. But this is not something that I would use in a personal life, and I'm not using it. I'm using it in my tools, in the cyber tools, when I'm providing my customers, okay, you are communicating with a specific URL, know that this is a known malicious one. But it is not on a personal level, it's a bit less relevant. And other than that, one additional thing that you can do as a developer, have a look on the URL. If all the information is sent in the URL as URL parameters, this company is not using best practice of how to develop secure code. Okay? Cool.
Thank you
Guys,
so much. Let's give a round of applause for Avisha.
Thank you very much.
Thank you.
Thank you.
I think the conversation can go on, and you can catch him in a break.